Hello and welcome to the Startups of London podcast. I'm your host Ozan and the founder of Startups of London. Today I'm joined by Eric Landau, founder of Encord, and it's a fascinating business. The description that I can see on the website is that it's an active learning platform for computer vision. So it does all sorts of things, AI-assisted labeling, model training and diagnostics, find and fix data sets, errors and biases. All-in-one collaborative active learning platform to get to production AI faster. First of all, welcome to our chat, Eric.
Yeah, thank you very much.
Yeah, it's really nice to have you here. I know how strong of an experience that you have as well as a background in this field. But before we get onto that, let's start off with your speculations and your feelings perhaps about the spotlight AI has been getting with all the discoveries around generative AI, Mid-Journey, ChatGPT and everything else. It has become more of a household name, right? We were talking it's going to be a big thing, and then we waited for 10 years and it never became that big thing. And all of a sudden, was it November last year or December? And it then became a big thing overnight. 10 years in the making, overnight, kind of like a situation, I think, there as well. How do you see all of this? Do you see it as a positive? How do you think it's going to change how people understand AI? Let's start with that.
Yeah, no, I think it's definitely a positive, especially that there's much more public attention on it. And I think it's just good for the general development of AI that a bunch of startups are now being built around things like the OpenAI API and ChatGPT, and a lot of people are thinking about it. But it is really it's a overnight sensation, 10 years in the making, as you said, where from our perspective, it's really been more about incremental progress. And the main change in November of last year when ChatGPT was released was just that the way that it was packaged and presented. So the technology hasn't really changed very much. GPT-3, which is the main model that ChatGPT is based off of, has been around for almost 3 years. And the capability has been, very similar to what you see with ChatGPT, except now it's built in a way that the public can see the power of AI directly and they can interact with it directly, and it's much more accessible. And that perceptive change is the main one, which has allowed OpenAI to, I think ChatGPT is the fastest growing application in history. So it really isn't a technological shift. The technology has been developing now for the last 10 years, but it's more the way that it's presented.
Yeah, I think that's a good point. I remember when I first read about ChatGPT a few years back, before last year, I think I first heard it like ChatGPT, and it was a mention of Geppetto, right? Have you heard of that? The GPT coming from that?
Yeah. I mean, there's a long history of these large language models, and the previous iterations of them, GPT-2, as you said, and BERT before them, and we've been in the space for a little bit of time, and I'm kind of watching the language part of AI develop, and it has felt more incremental. But with seeing ChatGPT now, it's pretty amazing to see like everyone now clicking in and seeing the power of these models.
It's crazy, and I think you've put it really well. It is more about the front end and the interaction interface, because there were some people who really understood how it worked. And they were saying, oh, AI is going to be huge. And people were looking at them like, I mean, Alexa doesn't feel like that. Like, it cannot get like a Spotify song right. So how is this going to happen, right? When, is it going to happen in 2050 or something? Yeah, as you said, with the front end and the interaction, the interface with the users, that's being established, I think what happened was we as humans have this inherent tilt to think like, in a way, we give them human attributes, right? So it becomes an emotional thing. And we think, okay, this is just creepy. I think that kind of like a very emotional connection happened in how people saw AI. And for the first time really got awakened in terms of the possibilities. Oh, wow, this is going to be really, really disrupting, right?
Yeah, that's right. It's tuning a model into an application which is very resonant to human emotions. And one of the reasons why we see less of AI in the regular world is because the bar and the threshold for performance for AI models for most of the applications that it works on is very, very high. So self-driving cars, they need to be right not 99% of the time, but 99.999% of the time, right? Otherwise, even 99% right will cause a lot of car accidents in the street. But ChatGPT or chatbot, it can afford to be right only 90% of the time or 95% of the time. And it can be trained in a way that people can interact with it very fluidly. So those two changes, the performance error threshold for the model and the ability to really interact directly with the public has been the main spark for, for the current growth and craze in AI, and more specifically generative AI.
How does thinking around computer vision differ or compare to thinking around generative AI or language-based models?
In a way, the fundamentals are the same, where the base of all these AI models is having the right data and the right training data. The main difference between these generative models or a lot of these foundational models is that they're trained in what's called an unsupervised way versus many predictive AI applications, or ones that are in kind of traditional computer vision use cases. They're trained with what's called supervised learning. Both require huge amounts of data to train the models, but one requires having labeled training data examples to learn from, and the other, you just give it the data by itself, and it kind of learns from the inherent patterns of the data. So supervised learning, you have to tell the machine what everything is. So an example is, you might have a video and you're showing it cups and chairs and tables, and for each item you have to say in the video, hey, this is a chair, this is a table, this is a cup. So you're pointing directly to what you want the model to learn. Versus unsupervised learning, you just give it a bunch of data and you say, here's kind of the general structure, and you need to learn from the structure of the data. And text lends itself very well to this, because if you give it Wikipedia, for instance, a large language model, you don't have to label anything. You just have to ask it to predict, given a sentence in a Wikipedia article, please predict the next sentence or the next word. And so that doesn't require any additional human labeling. It's just giving it the data with a task that allows it to learn from the data by itself.
That's a very, very good point, actually. Yeah, because text itself is an abstraction. And according to some philosophers, it is the way that the human intelligence has actually developed, right? Thinking through language is what in most ways defines most of our intellectual existence, abstract concepts, being able to compare them, etc. But with vision, there is another layer there. What we see is not always describable in words, as humans as well, actually, right? There's an assumption layer that we make. We might look at an object and think that, okay, this is a circle, and then it will rotate and we will realize it's a bottle. So there is always that uncertainty that the human brains try to work through in daily life, make the assumptions. So I can understand it is a much layered and complicated, perhaps, barrier to break. Is that off the mark? Do you think there's some truth in that?
No, I think there's some truth in that. You could say that language is, in a sense, the natural operating system for the human mind. Because if you're perceiving things visually, even my example that I gave before, where you have a table and a chair and a cup, we're parameterizing the visual concepts with words. So the word chair describes the thing that looks to us like a chair. So the concepts are really encapsulated by the linguistic patterns that we have. And that helps shape the way that we think about the world in a more intrinsic sense. Of course, language is not the bare bones of how we think about things. Everything linguistic is pointing to some other higher level concept. It's just a very useful way from a human perspective to organize our principles in the way that we're interpreting the world. So the mental model that we have tends to really be underwritten by language itself. So I think there is something there. It probably requires a little bit more thought of how it works, but it's not something that I've really considered too deeply myself. I think it's a interesting observation.
I think that's incredibly fascinating, and this is the first time I'm thinking through this as well. But because in a natural language model, the abstraction is also the level we're operating. So when we say chair, chair essentially is a placeholder for whatever the person is going to understand, right? A chair might mean visually it might mean a million different things, but we use chair as a placeholder. So that's the level that we operate. So when text completes and it sounds right, it's easier, I think, for us to ascribe a certain intelligence to the engine. Whereas in the visual realm, and perhaps because the visual cortex, the back of the brain, the occipital lobe, if I'm not mistaken, is the first part of the brain. It's the biggest part of the brain as well. We have a huge processor for understanding the nuances and the light and the direction and the speed of objects. And that's basic to our survival. So it is much more layered. So I think it is also easier to find faults in an AI system when it competes through the visual recognition rather than the chat. And I'm guessing that's kind of diving into the realm of Encord. And maybe with that segue, do tell us about the business and what the model is and what are the technical challenges you're working on.
Sure. So I think you did a good job introducing the company in your introduction, but not to repeat anything, we are what we call an active learning platform. And what that means is we work with a lot of companies and institutions and groups that are building computer vision models themselves. And we are the infrastructure layer for their training data. So both in managing their training data, annotating their training data, evaluating with respect to their model and their model performance, we kind of handle the base layer to make sure that all of the potential training data problems that they have are solved. And so that they can focus on really building strong models and then deploying them into production environments and making sure that they work in practice. So what we offer is a software platform to help solve these various problems and work with a lot of sophisticated AI companies that have a huge corpus of training data and need these things to be resolved in efficient and scalable ways.
So if I were to speculate, just from a market and market size perspective in terms of the commercial potential for the business, please correct me when I'm wrong here. There is a certain interest that has been proven by the functionality of AI, especially around generative learning and also in computer vision. Companies want to use these, but they don't necessarily have the infrastructure to be able to use that. They don't know how to create and perhaps work through their data sets. And that expertise is very expensive. So you are a layer of service in a way that is enabling these companies to be able to use their own models. Is that the case?
Yeah, it's an infrastructural software platform to solve the more granular training data problems that these companies have.
Is there an example you could perhaps share with us so we can maybe understand it more?
Yes, I think that's a great idea. And an analogy is a lot of these companies, they train their models in cloud infrastructure, so in AWS or GCP, and they use the Kubernetes clusters and the GPUs offered by these larger cloud infrastructure purposes. The analogy is we do a similar thing, but on the training data layer. And to give an example, back in the supervised learning context, where you need to label a ton of data to feed it to the models to actually train the models properly, what a lot of companies were doing before Encord and similar companies in our space was they had to build their own internal tooling to handle how to annotate this data and how to do it in a way that was semi-efficient and scalable. And it's very hard for companies to build this internal tooling themselves because it's quite expensive and requires a lot of maintenance and a lot of work. So one of the main components that we offer is this toolkit to be able to annotate data efficiently and do it in a way that can also use automated strategies to generate a bunch of labels quickly. So if you have a car that's driving on the street and you're trying to train an autonomous self-driving system, you want to label all the pedestrians. And the way that this was being done before was you would just get 1,000 people to go in and draw boxes over every pedestrian that they see in a video,
or use reCAPTCHA. That was the purpose of it, right? Like
that. I actually have an interesting story on that, but which I can get to in a second.
I'll remind you in a second. Yeah.
Yes, and people were using these other kinds of strategies as well, but the main way was just shipping the data overseas, getting it annotated by factories filled with people, and then having it sent back and corrected and respecified and then sent back overseas, and et cetera, et cetera. And that process is just very slow and cumbersome. So we offer this annotation toolkit and platform that allows you to do all the pedestrian labeling in a much more intelligent and scalable way. And one of the strategies that we use is this idea of micromodels, these specialized models that are trained to do one specific thing very well. So you have a very quick model that just focuses on pedestrians in a video, and you use that to help label a bunch of pedestrians quickly. So that's one of the toolkits that we have to provide to these AI companies.
Okay, it makes more sense, more tangible now, for at least in my head. With that in mind, I'd like to ask you, before we go into the recapture thing, for most startups that I have interviewed, as we've spoken over the years, there is usually a few points, like the first big wins. These are sometimes some new big clients, sometimes investment. But let's not focus on the investment side, but rather on the first big client, big win for the business. What was that? Like, what's the story that you could tell us, perhaps?
The very first big win, I would say, was getting into Y Combinator, which happened after the first year. So the company started with my co-founder and I, and we built the initial product during the pandemic, essentially. So
you were 2019-20 cohort?
Yeah, 2020, exactly. And so we were doing it from our couches, and we spent a lot of time kind of developing it ourselves. And we're thinking about, okay, we have this product now, and we can think about raising money. We are based in London, and my co-founder had the idea, let's apply to Y Combinator. And originally I was skeptical because the acceptance rate of companies to get into Y Combinator is very, very low. I think at the time under 2% or something like that. But we spent the time, wrote the application, then we're lucky to get an interview, did the interview, and then we're very, very lucky to get in. And I think that really changed the trajectory of the company, because looking back on it now, if we had gone out to try to raise money from where we were, we would have just failed. I think we would have failed pretty badly. So it was a huge win to get into YC.
It's such a badge of approval. It's amazing. It's a big legitimacy for the business, and investors, they want to take risks, but it's just like nobody got fired for buying IBM type of a tale, right? When you invest in a company that's gone through Y Combinator, the person who's making that decision will not get fired, because they will say, hey, look, like they've gone through Y Combinator, right? At least. And that really turns out to be incredibly important when people take risks. But yeah, carry on, please.
No, definitely. And it's that. So it's the validation that you get and the signaling effects, but also the mentorship and the network and the advice, and all of that was very positive for us. And I think put us in a very good foundational place to, build the business from just a kind of a product that we had into a proper business. So that was definitely a huge win, and really, brought us to it was one of the pieces that brought us to where we are today.
Amazing. In terms of the customers, the B2B sides, or some partnerships, big partnerships, anything that comes to mind?
Yeah. So the other big win that we've had since is to get some of the best AI companies in the world to also work with us. So it's really a pleasure to see some very sophisticated companies that are building, production scale models that are working at a scale that is quite impressive, to see how they work, and, see what problems that they're having, and allow us to build a product that really serves to them well. So serves to the most sophisticated AI players in the space, because if you build to them, then all the new companies that are coming up now, the ones that are starting to build POC models, for instance, they will have a similar set of problems as what the more sophisticated players will have right now. So in a way, we're allowed to see the future by working with the companies that have built their entire model infrastructure and gotten models to work in the real world. And some of those, include companies like Tractable and Iterative Health and VizAI, and these companies which we're very impressed by, and we're glad to work with.
Amazing. I mean, this is such an exciting field, and the real life applications are what makes it exciting in the way that I see it. So what jumps at you? What do you find most exciting in terms of the real life applications of your potential customers or your current customers, or potential use cases for what you're working in?
Yeah, so one of the areas that we work in quite a lot is in healthcare. And there are a lot of subspecialties and sub-applications within healthcare. But I think AI just applying within the healthcare field has the potential to really turn healthcare from being a de facto reactive system to being a proactive system. So to focus more on preventative measures and finding things early in a way that you can treat things much faster than if you wait a long time and just have to go at the end of the cycle rather than beginning of the cycle. So a lot of these diagnostic use cases of finding cancer within gastroenterology use cases or within radiology, detecting strokes, all of these things which we are working in, I think are very exciting and have the potential to really make a transformative effect within medicine.
Amazing. If I were to speculate on that a bit, so there was this approach. I was having a conversation with a really smart person that I respect. He was running a marketing agency back then. And we had a chat about how correlation is a lead indicator rather than causation in some cases, especially in complex systems. You don't always understand why something happens, but if you see correlation, okay, that usually can save you a bit of a time. Correct me if I'm wrong here, because you have more in-depth information on this than me. I'm assuming there are cases, brain imagery, for example, when AI works through it, catches something the human eye has missed. Yes. But then there are these other category of cases where it assigns a probability of a risk of an illness in the absence of any physical, clear, identifiable, causation-based, at least, visual signals. Is there any truth in that?
Yeah, it's interesting you brought up this point because, this is one of the problems that late-stage companies have is how to decorrelate correlation and causation and how to make sure that when AI models are making decisions, that they're making the right decisions and on the right factors and have the right kind of explainable concepts that you would expect from a human domain expert point of view. So one of the tools that we have is, in our active learning toolkit is a way of breaking down model performance such that you can understand it better with respect to the data domain. And if you find that the model is doing these kinds of predictions, within a specific set of conditions that are happening with the data, which are not actually causally linked with the actual illness or inference result that the model is trying to do, then our tool will help find that in a way that is a little bit difficult now for companies to understand. So this is one of the problems that you have once you have a model that's actually working, is trying to really understand why the model is doing what it's doing and to make sure that it's making the decisions based on the right factors. And that's one of the things that we've seen from our these sophisticated companies that we're building towards as well.
This is what makes it the most exciting, perhaps, invention of our century. Even I think the model doesn't know. The model, of course, doesn't know. The model doesn't. It's the conscious thing, right? It doesn't even know what is happening. But a combination of data points, let's say 100,000 of them, show a statistically significant change, and then that's our conclusion, kind of. So it is actually an amazing way for us to discover the reality, the fabric of health. Also, social application areas are very exciting for me. My background is in social sciences, so I can't wait for the day where we apply these models in a meaningful way and say, hey, you know what, when we as a society do these things, it actually decreases the level of crime, or it increases the level of innovation. We don't understand why that happens, but hey, change this, and then, okay, this happens here. And then before we understand, we can do some of things. That was kind of my point. Up until this point in history, we needed to really understand the mechanism of how something works before we were able to apply it. But now I think AI is training us as well, yes, in a way, to think differently, right? So maybe we can apply some of things before we understand how they work, as long as there is statistical significant data there.
Yeah, I think that's a great point, and it's very fascinating to see this evolution because there's kind of two sub points here. One is that well, the normal way that a computer programmer would come in and try to fix or debug a system is to really decompose it within the code itself in terms of, all right, what in the system is doing the wrong thing, and then I can go in and fix that particular thing. But these models are so complex and have so many layers that we can't do that directly. So we have to develop all these indirect methods of trying to correct and improve the model. And in a way, it's going to develop in a similar way to how we try to improve human behavior, right? We can't go in and affect neurons directly in people's brains, but we have things like therapy. So, you talk to a person, you try to understand why they're doing what they're doing. And you have all these other interventions that in this indirect way are trying to move things in the right direction. So we're going to have like a kind of AI therapy which is in parallel to how we're doing it with people now. And the second bit is understanding that the model is as good as the data that it's being trained on. So if you give the model a lot of data that's wrong, then it will just come to the wrong conclusions. So instead of trying to understand the model directly or the AI application directly, put your attention on understanding the data that's feeding it. So in this case, there's also a human analogy where if you give a student a textbook with a lot of factual errors and a lot of misspellings, that student will learn misinformation and they won't learn how to spell. So let's focus on making sure that the textbooks are correct, before feeding it to the students. And I think those two things are, these two processes are going to evolve with more sophistication as we get more of these models to work in production use cases.
Well said. Well said. It makes me think. The ChatGPT stuff made me think, okay, the humans will have a more curative role rather than a creator role in how some creative industries are heading. And I think that's not so bad because we always talk about this tension, especially when you start a new craft, an art, and any artisanal pursuit. There is a gap between what your hands and you are able to create, the quality of your output versus your taste, your gusto, right? There's this gap for a certain period of time, for maybe 10 years. You really don't like what you're creating and you have to stay within that painful state if you want to be a great creator. And once your dexterity, your hand skills or like your painting skills or your prose matches your gusto, and then you become like a really good artist. Now, maybe we are cutting that time down quite significantly, and the people with that gusto, that taste, that curator mentality can come up with amazing stuff. And just like that, it makes me think maybe what you said, the data that we feed into these systems are so important. So maybe a similar approach would or could be useful there. What do you think? A data set curator, or maybe there already is, right? How do you curate the right set of data? What metrics do you look at in complex systems? So going with the analogy of, I want to train AI on social policies, but what data do I put into that system to be able to get good conclusions? Type of a thing. What do you think?
That's exactly what we're doing. So, and those are the exact problems that we are thinking about a lot in our company and the solutions that we're building as well. And I think this, as you say, this taste skill gap, which happens with anyone that's trying to, be creative, will diminish, and the human role won't go away. It'll just be pivoted to. We're going to be the editors, the therapists, and the educators of AI, rather than the generators of the content ourselves. And part of that is really understanding, well, if you're doing AI therapy, like how should you be doing it? If you're curating the data and the textbooks that these AI students are going to be learning from, how do you do that? What metrics are you looking at? What are the best practices to be making these decisions? And those are the problems that we are working on at the moment. And that's what I'm quite excited about as well within our company.
Amazing, Eric. Final question. What is the big milestone in front of the business and you as the founder? What's the big goal for the coming year?
Really, it's just continuing to grow, keeping everything on track and on pace, and the set of problems that you face when you're a 2-person company is different when you're a 10-person company, which is different from when you're a 40-person company.
How many people are you?
Around 40.
Okay. And by the way, are you hiring for any roles? Sometimes we use this platform as like a way to make a quick announcements. If you're hiring for anyone, do let the audience know.
Yeah, I think the best way to look at all the roles we're hiring for is going to our website. We have a careers page, and you can see all of the different roles. We're always looking for strong people, strong full stack engineers, strong ML engineers. We're hiring quite a bit in the go-to-market function. So one of our goals is to really systematize our commercial function and to get the engine to be roaring outside of just my co-founder and I being more involved in it. So having that kind of growth engine is something which every company and startup aspires to, and which we are making very good progress on right now.
Wow, Eric, what an insightful conversation this was. I feel like I've upgraded my understanding of AI at least by a meaningful few percentages. So thank you for taking the time and joining in our chat. It was lovely to have this conversation with you.
Yes, and thank you for having me as well. I had a lot of fun.